In today's video, we are going to take a look at inverse functions. You've already heard the word inverses before when we looked at matrices. Keep in mind, an inverse looks at undoing an operation. There are some different properties that we're going to look at when we're looking at inverse functions themselves, looking at y equals equations. So to begin with, an inverse function is defined as follows. If f is a function, then the inverse of f, which we denote f to the negative first, that means f inverse, is the relation obtained by interchanging the two variables. So switching the two variables. That's what makes something an inverse. Looks at interchanging the two variables. Now we're going to perform a little bit more with these operations, but that's kind of the heart of it, is we're going to be interchanging the two variables. Our x value becomes our y value becomes our x. However, instead of dealing with y, we're dealing with this f of x notation, which then we'll be dealing with f inverse of x once you perform an inverse. Please keep in mind, if we start with a function, the inverse may or may not be a function. So if our initial function that we're looking at has to pass the vertical line test, when we perform the inverse on it, it may not pass the vertical line test. It might not. It just completely depends. We are going to start by inverting a linear function, just having the process of working with a really easy function to invert. Then we'll move to a quadratic, and lastly, we're going to look at exponentials. So we are going to invert this linear function. First thing I'm going to do is, instead of seeing the f of x, I'm going to write this as y equals, because if you remember, f of x is just your dependent variable, which is your y. So this is the exact same thing. I haven't changed anything. Now, before I actually go through and start looking at the inverse, I'm going to graph this. So in your calculator, grab out your calculator. In my y equals, I'm going to type in 5x plus 15. That's the graph that we're looking at. Now I'm going to graph it, and we have a nice line. Y-intercept's 15, slope is 5, etc. Just like you normally would have. Okay, I'm going to copy this into my slide so you can see what this looks like. So that's our f of x equation. Now we are going to actually perform the inverse operation. To find the inverse of this function, we are going to interchange our x and y value. So the y value becomes the x value becomes the y. Everything else is still the same. However, when I'm finding the inverse function, it's going to have to be solved for y. Okay? We always find our equations so that our dependent variable is sitting by itself. So I have to solve this for y. So I'm going to subtract the 15 over, divide both sides by 5. I'm going to switch this around so it's normal. Therefore, y equals 1/5 x minus 3. Okay, now we're almost done. To find the inverse, you first, to make it easier, rewrite f of x in place of f of x, you write y. Next, you interchange your x and y. Next, you solve for that new y value. Lastly, I found an inverse. Inverse notation is f inverse of x equals 1/5 x minus 3. You can't forget that last step. That's what denotes this is an inverse for my initial function. So now I'm going to graph that. So going back over here, I'm going to graph this on the second one. And this is 1/5. So I need to put parentheses around that. 1 divided by 5 x minus 3. I'm going to turn off my first graph. That way we can see just what this one looks like. So to turn it off, I have to have the equal sign flashing. Hit enter. So see how it's not highlighted anymore? To turn it off again, you just have to cover up the equal sign, hit enter, and then off it goes. So now when I graph this one, there is my graph. So I'm going to copy that one in. So there are my two functions. I have the initial one, my f of x function, and I have my inverse function. Okay. So I'm going to come back to this page in just a little bit. But for now, I'm going to move on, and we're going to look at quadratics. We are simply going to look at a square function. I'm not going to look at any adding and subtracting pieces. I absolutely can. They definitely get more involved once we do that. So just like before, when I'm going to invert the square function, the f of x becomes y equals x squared. So I'm going to take a look at this in my graph again. So going to my graph, go up to y equals. I'm going to come back to these two, so I'm just going to turn them both off. So now I'm going to do this in line 3, which is just x squared. Let's try that again. X squared. So now I'll graph that. And you should all know this is the shape of a parabola. We just finished our quadratic unit. Okay, centered at 0, 0, no shifts. So I'm going to copy this over. So there's my function for f of x. Now I'm going to do the inverse. So I first rewrote it with y equals. I interchanged those two variables. X is what your y was. Y is what your x was. Now I have to solve for y. So what do I do to both sides? Square root. So y equals the square root of x. Square root of x. Just the square root of x? Let's look for a second. If I'm solving, because right now I'm rewriting this so I could solve. If I gave you x squared equals 4, what does x equal? 2? Sure. Just 2? No. 2 and negative 2, both. It's the positive and negative square root. So, interchanged x and y. Solved it for y. Rewrite it as f inverse of x equals positive and negative square root of x. There's your inverse. You just calculate the inverse of a square function. So now when I go to graph this one, I'm going to turn this third equation off so it's off when we look at it. So we have the square root of x. Second, square root sign, x. Now, if I graph this, you're missing part of it. You're missing the bottom part of your parabola. It's a sideways parabola. So in order to get your bottom part, that's where the negative goes in. The negative sign, second, square root, x. Now graph that. There is what I needed. Okay, copying this one over. So there is my original function and my inverse. Now, if I'd be using a square scale on my calculator, this might be easier to see. But what I need you to realize is there's a relationship between a function and its inverse. Between a function and its inverse. Now, if you think about this, all of your x values became your y values. All your y values became your x values. Now what I'm going to do is I'm going to put these two graphs on the same screen so you can see what happens. So going back here, since I've got this one turned on, I'll do my square functions first. So I'm going to turn on number 3. I'm going to hit enter now to turn it back on. Just go over that equal sign, hit enter. Graph. Do you see any relationship with the two? Do you see anything that takes place? So I'm going to copy that screen over. So there are my two together. So if I look at this, My x values became my y values. My y values became my x values. So if I put in my initial function, if I put in 2 for x, out spits y. So in the inverse, my x becomes my y becomes my x. So this point here was the point 2, 4. So now if those 2 points interchange with each other, that point is now 4, 2. And I can do all of those along the way. The point 3, 9 that was on my initial function is now 9, 3. And backwards. If I wouldn't have done the positive and negative, I would have missed out. This is negative 2, 4. Now that's 4, negative 2. So just keeping in mind all the different pieces of information, each value ends up kind of flipping around a little bit. And we call that part that it's flipping around a reflection line. There's a line of reflection, and that line of reflection falls at the equation y equals x. Y equals x, because it's exactly where each of the y values become x values and your x values become y values. This happens also for linears. So I'm going to draw my graph now with both of them together. So if you notice this line where they cross, my f of x and my f inverse of x, they cross at the point that they both completely share, where their x value is their y value therefore is your x value. So if I take a function and I find its inverse, the result is a reflection over the y equals x line. So if you know some points, you can easily reflect them over and find the rest of it. So now we are going to look at inverting a log. Okay, so now that we've done our basic ones, now we're going to look at how do I invert a log? What happens when I invert a log? And then we'll talk about a couple other properties that we see. Besides the reflection piece, there's a few other things that we see. So when we invert a log, I am going to first graph this. After, of course, I rewrite this as y equals log base 2 of x. Now, in order to put this in your calculator, there is not a base of 10. You therefore have to plug it in using the change of base process. So when I go to my calculator, I have to put this in as the log of x divided by the log of 2. So again, that change of base process coming up. That is to graph it. Okay. So go ahead, take a moment, put this in your graph. So log of x, close your parenthesis, divided by log of 2. Graph that, and you get your log. There's our log equation, or log graph. So I'm going to copy this over. In log equations, and I'm going to get into more specifics of graphing logs by hand, but all logs have a vertical asymptote. If you remember back to exponentials, all exponentials have horizontal asymptotes. All logs have vertical asymptotes. So it never crosses that y-axis. So now that I have the initial function graphed, now I'm going to find the inverse of it. So I interchange my x and y. Okay, now I have to solve for y. Why is my argument? How do I solve and get y by itself when it's sitting right there? What do you do? Rewrite it. Properties, whatever you want to try. Rewriting it, easiest way to go about it. Rewriting this, my base, to my logarithm, which is my exponent, equals my argument. Hey, look at that. I have it solved for y. Then, after I solve it for y, I rewrite it as the inverse. F inverse of x equals 2 to the x. The inverse of a log is an exponential. The inverse of an exponential is a log. They are inverses of one another. One of the reasons we use logs to solve for exponents. Okay. So the inverse of a log is an exponential. The inverse of an exponential is a log. So now I'm going to graph this. You can easily graph 2 to the x in your calculator. So go ahead, graph that, and I'll pull the graph in here once I'm done. So there's a graph of my inverse. It's an exponential. Exponentials have horizontal asymptotes. Now let's think about this. I talked about this as a reflection over the line y equals x. So if I pick some value along here, along that x-axis, which is part of my asymptote, that might be the point 5, 0. X and y flipped, that's now 0, 5. At another point here, which is 10, 0. Reflect that, that's 0, 10. So that's why it's making that vertical line. That horizontal line is becoming the vertical line. Okay. Now let's put them together. And when I put them together, I now have a line of reflection in there. So in this middle graph now, I have both of these. My log, which has my vertical asymptote, my exponential, which has my horizontal asymptote, they reflect over that line y equals x. So with these, not only can we figure out what the graphs look like, we can find out what their functions are, but if I give you a couple functions, you should be able to tell whether they're inverses of each other. And to do that, we do not just do the inverse operation of it. We cannot just interchange our x and y and solve it. If two functions are inverses of one another, or if a function and a non-function are inverses of one another, their composite, f of g of x, or g of f of x, either order you go, the result is x. So to determine whether something is an inverse, I have to do one of these two composites. So let's pick f of g of x, no particular reason. Now you have to remember composites. G of x is x over 2. So this is f of, instead of g of x, it's now x over 2. Because g of x equals x over 2. So I just substituted that in place of it. Now it's f of that. So in my f equation, where there's an x, I put x over 2. So that's 2 times x over 2. When I multiply it, I get x. Since I get x, these are inverses. So the answer to this is yes. Again, I can also do g of f of x. Sometimes one way might be quicker than the other way, but either process is going to give you the exact same situation. So this is taking functions, finding their inverses. It leads us into logs. We're looking at our logs here because logs are the inverse function of exponentials. They undo one another, which is why we use logs to solve for exponentials, and we use exponentials to solve for logs. So you have to feel really, really comfortable flipping back and forth between the two forms. In the next video, you're going to watch graphing. I'm not going to spend a lot of time on graphing. It's using transformations of graphs, but make sure that you follow through with that too, because it really is just a reflection of the line y equals x.